Hi, I'm Adrienne, and I'm here to talk about validity and reliability. Validity refers to the quality and degree to which a study reflects the concept it intends on measuring. This usually answers the question of, does the study measure what it's supposed to be measuring? Some key terms for validity. One is operationalization, which is defined as translating a construct into a functioning and operating reality. The term construct refers to the population of interest in your study. The term operationalization refers to the sample. Construct validity is the approximate truth of the conclusion that your operationalization accurately reflects its construct. And this refers to the general case of translating a construct or population into an operationalization or a sample. Translation validity focuses on whether the operationalization is a good reflection of the construct. In other words, translation validity looks at how accurate you were at translating your construct into the operationalization. There are two types of translation validity. And the first one is face validity, which answers the question of, is the program what it says it is? Face validity takes a look at the operationalization to see whether, on its face, it seems like a good translation of the construct. Often this is seen as a weak measure because it is a subjective judgment call. However, this should not be ruled out because it can still be a valid measure. Consulting an expert in your area you're interested in studying will help make face validity more convincing. An example of assessing face validity would be assessing the face validity of a reading ability measure with help from experts on reading ability. Content validity is the second one of translation validity. It's the operationalization is checked against relevant content domain for the construct. This is an assumption that there is a good detailed description of the content, which is not always true. The definition of the target group and basic information related to the type of program being assessed can help create a checklist. This checklist can be used to help make sure the program meets the necessary criteria. Okay, the next one is criterion related validity. And there are four underneath it. The first one is predictive validity, and criteria validity basically is making a prediction about how the operationalization will perform against some criterion. Okay, and for predictive validity, the operationalization's ability to predict something it should theoretically be able to predict. An example would be reading ability should predict how someone would do in a journalism-based profession. Okay, the second type of criterion-related validity is concurrent validity. The operationalization's ability to distinguish between groups that it should theoretically be able to distinguish between. An example of this is distinguishing between individuals suffering from anorexia and those suffering from bulimia. Results are powerful when you can show that you can discriminate between two groups that are very similar. Okay, the third one under criterion related validity is convergent validity, and this is the degree to which the operationalization is similar to other operationalizations that it theoretically should be similar to. An example would be evidence being gathered about other daycare programs to show that they are similar to the daycare program you're studying. The final type of criterion-related validity is discriminant validity. This is the degree to which the operationalization is not similar to other operationalizations that it theoretically should be similar to. Evidence can be gathered about other early childhood programs that show that they're not similar to the program being studied. Okay. Next is the nomological network. And this is basically just a lawful network that helps provide evidence that your measure has construct validity by developing a network that includes the theoretical framework for what you're trying to measure, empirical framework for how you will measure it, and specific linkages related to the two frameworks. The purpose of the nomological network is to make clear what something is or means. Laws of the network may relate observable properties or quantities to each other, different theoretical constructs to each other, theoretical constructs to observables. Some laws within a network must involve observables. Elaborating the nomological network in which it occurs can help learn more about a theoretical construct. In order to add a new construct, the construct must generate laws confirmed by observations or reduce the number of nomologicals required to predict some observables. Operations that are qualitatively different overlap or measure the same thing when their position in a nomological net ties them to the same construct variable. The checklist for construct validity contains three things, and they are semantic net, control, and data to support your theoretical view. The semantic net is the set the construct you want to operationalize within a semantic net or a net of meaning. Control is providing direct evidence that you control the operationalization of the construct. And data to support your theoretical view is providing evidence that your data support your theoretical view of the relations among constructs. There are several threats to construct validity. Inadequate pre-operational explication of constructs is defining what is meant by the construct was not done adequately. So they didn't really define the construct very well. Solutions involve thinking through concepts better, using methods to articulate your concepts, getting experts to critique your operationalizations. A second one is mono-operation bias, which is a failure to capture the program's concepts completely by using single versions at single times and single places. A solution to this threat is to implement multiple versions of the program. The next one is mono-method bias, which is similar to mono-operation bias, but it is a failure to capture the program's measures or observations. A solution to this problem is to try to implement multiple measures of key constructs and demonstrate that the measures that you use behave as you theoretically expect them to. A couple more of the threats are interaction of different treatments, interaction of testing and treatment. Another one is restricted generalizability across constructs, which is just unintended consequences. And the final one is confounding constructs and levels of constructs, which is basically just a labeling issue. There are also some social threats to construct validity. And these are hypothesis guessing, which participants guess the purpose of the study and base their behaviors on what they think is expected. The next one is evaluation apprehension, which is anxiety about testing that can interfere with the results. And the final one of social threats is the experimenter's expectancies, which is researcher bias that results about the way that they feel the study should happen or the results that they expect. Let's step back to the multi-method matrix and pattern matching. There are ways that you assess construct validity. And the multi-trait, multi-method matrix is just a table of correlations arranged to facilitate the interpretation for the assessment of construct validity. And pattern matching is linking of theoretical patterns and observed or operational patterns. And some common tests that we can use with SPSS for this is ANOVA or t-test, and these will help test for significance. Now on to reliability. Reliability is the quality of a measurement and is the consistency or repeatability of your measures, which is better defined as being able to get the same results over and over and over again. One thing related to reliability is the true score theory, and it's a postulated theory. It's not proven about measures of how the world operates. Every measurement is a composite of true ability plus random error, which is represented in the formula X equals T, which is true ability, plus E, which is random error. The true score theory is important because it reminds us that most measurement has an error component. Another reason it's important is because it's the foundation of reliability theory, which is no random error equals all true score. No true score equals all random error, which equals zero reliability. Another reason that is important is because it can be used in computer simulations as a basis for generating observed scores within certain known properties. One main problem with the true score theory is that it's not an accurate reflection of reality. We've got some errors that happen with reliability, and they are random error and systematic error. Random error is caused by any factors that randomly affect measurement of a variable, which can be a person's mood. There are no consistent effects across an entire sample. Observed scores are usually pushed up or down randomly. And finally, with random error, it's usually considered noise because it adds variability to data, but it does not affect the average performance of the group. Okay, with systematic error, it's usually caused by factors that systematically affect measurement of a variable. The example given was children in a classroom taking a test and noise outside, which could have been a lawnmower or something. But this noise can affect the testing. And something else about systematic error is that it's usually either positive or negative, and it is considered bias. There are a lot of ways to prevent measurement error. One way is getting feedback from respondents. which can be done through pilot testing. Another way is to train interviewers or observers. You can also double check your data thoroughly. And also you can use multiple measures of the same construct. There are different types of reliability. The first one is inter-rater or inter-observer reliability, which is the degree to which different raters or observers give consistent estimates of the same thing. And this calculates the percent of agreement between raters, or it can calculate correlations between observers that are continuous. Another type of reliability is test-retest reliability, which is used when the same test is administered to the same people on 2 different occasions. Timing in test-retest is very critical because the shorter the time gap, the higher the correlation, and the longer the time gap, the lower the correlation. The third type of reliability is parallel forms reliability, which is 2 parallel forms are created. There's usually a large set of questions to address the same construct. And these questions can be divided into 2 sets. The problem with this, dividing them into 2 sets, is that the 2 sets aren't equivalent to each other. The fourth type of reliability is internal consistency reliability, which is used to assess consistency of results across items within a test. A single measurement instrument is administered to a group of people at one time to test the reliability. And this example of targets kind of talks a little bit about reliability and validity. When you're so far off from your target, you're considered to be reliable but not valid. When it's just all over the place, constantly trying but not hitting the target, is considered to be valid but not reliable. And when it's going across one part, it's considered not reliable or valid. But when you're hitting the center every time, then you're considered to be reliable and valid. Thank you.